Hello friends, welcome to my YouTube channel. My name is Prathamesh. Without wasting our time, let's begin. And if you like, please like, share, and subscribe.
Relying on a single, monolithic large language model to handle every phase of enterprise software engineering creates an immediate bottleneck. This dependency creates a rigid trade-off, the latency, cost, and accuracy trilemma. Demanding high accuracy slows down inference and escalates compute costs. Conversely, optimizing for speed and cost shrinks the reasoning capability required to map intricate enterprise architecture. Basic AI code completion tools are trapped in this zero-sum game. They trade quality for speed, or speed for quality, making them inadequate for an end-to-end development lifecycle. IBM Bob is built to bypass this limitation. It operates as an AI-first orchestrator designed to manage the entire software development lifecycle, rather than a standalone coding assistant. Instead of feeding every prompt into one isolated model, an orchestrator splits that workload, coordinating specialized, role-based agents that execute tasks in parallel. By dynamically routing multimodal workloads and enforcing active security directly inside the IDE, Bob removes the structural bottlenecks of traditional AI coding. Distributing tasks across specialized models allows the system to balance the competing demands of the trilemma, achieving the speed and accuracy that a monolithic model cannot reach simultaneously. To understand how this works, we need to trace a complex developer task from the exact moment it enters the IBM Bob ecosystem. The input immediately hits the Bob orchestration engine, deliberately bypassing the default language model assignment. In microseconds, the engine calibrates 3 metrics against the incoming payload: reasoning accuracy, acceptable latency, and strict operational cost limits. These diagnostic results dictate the immediate branching logic, preparing the engine to dispatch the task across parallel routes. What is typically a rigid, linear prompt pipeline becomes a highly responsive, context-aware dispatch system. For heavy reasoning tasks like system scoping and architect mode, the engine routes data to Anthropic Claude to maximize accuracy. Simultaneously, routine formatting or minor refactoring tasks are sent to open-source models like Mistral to ensure near-zero latency. But enterprise engineering often involves massive legacy modernization, such as translating decades-old COBOL or RPG into modern Java. The designated specialized target for these dense workloads is the IBM Granite family of models. To ensure these specialized models operate with accurate business context, the system relies on the Model Context Protocol, or MCP. MCP acts as the integration bridge, allowing models like Claude or Granite to securely hook directly into external databases and the enterprise systems teams already utilize. Through dynamic task-to-model specialization, every single specific subtask in a project is executed at its theoretical maximum efficiency. Running autonomous agents in parallel across multiple models introduces serious security risks if left unmonitored. Traditional development catches these risks post-generation during CI/CD pipeline checks. Bob operates on a strict principle of security by design. Instead of waiting for a pipeline test, Bob deploys a continuous active security agent directly inside the developer's local IDE environment. This agent executes real-time corporate policy enforcement on all newly generated code. It continuously intercepts returning data packets to scan snippets for exposed sensitive information. It simultaneously runs intelligent secrets detection to prevent API keys and credentials from being hard-coded into the project. If a snippet fails the check, the agent acts as a stripped firewall, entirely blocking the code from reaching the commit interface. Pushing security this far to the left collapses the DevSecOps feedback loop. Vulnerabilities are neutralized entirely before they ever exist in the local codebase. Managing autonomous workflow agents across code, tests, and pipelines requires absolute traceability. To enforce this governance, architects rely on the BobShell CLI. This dedicated command line interface creates a permanent, undeniable record of the exact model routing decisions for every single subtask. Crucially, it also logs all security clearance data, attaching an immutable proof of policy compliance to each specific code commit for enterprise audits. These terminal logs convert opaque AI generation into a self-documenting, highly repeatable process. The BobShell CLI provides the observability and control necessary for organizations to adopt autonomous AI agents while meeting enterprise compliance standards. Looking at this complete architectural map, we can track a developer task from the initial prompt through the orchestration engine router to the specialized models, past the IDE security firewall, and finally into the BobShell CLI logging terminal. Routing tasks based on exact cost, latency, and accuracy metrics solves the initial trilemma. Teams achieve high-speed parallel execution without relying on a monolithic bottleneck. This orchestration coordinates every stage of the lifecycle, automatically generating test coverage and managing the promotion of applications across different environments. With all of these discrete architectural components snapping perfectly into place, the limitations of isolated, reactive AI coding tools are eliminated. IBM Bob functions as a secure, orchestrated engineering partner, embedding intelligence into every phase of the software development lifecycle. Most AI developer tools today operate under a fatal limitation. They are strictly isolated text predictors. They excel at writing a fast function in isolation, but ask them to execute a system-wide architectural change, and productivity violently hits a wall. This timeline shows the standard development lifecycle: discovery, coding, testing, deployment, and maintenance. Current AI copilots are trapped within a single phase, ignoring surrounding infrastructure. IBM Bob operates differently. As an AI-first partner driven by agentic workflows, Bob orchestrates the entire system concurrently. It directs specialized agents, dynamically routing tasks to govern every phase from discovery to continuous integration. To test this architecture, we will track a workflow that immediately breaks standard copilots, modernizing a legacy enterprise system. Managing thousands of interdependent legacy nodes requires visibility across every phase, or the refactor collapses under the weight of its own complexity. Imagine opening an engineering ticket with a mandate to modernize a monolithic environment that has been running continuously since the era of mainframe computing. Pointing a standard language model at this codebase causes immediate compilation failures. The model guesses at local variables while remaining blind to the vast hidden architecture. Because of this risk, Bob enforces architect mode as a mandatory first step. The process begins with raw developer input, an unstructured idea or a loosely defined feature request. Rather than immediately outputting raw code, architect mode translates that concept into a highly structured logic tree, clarifying exact goals and mapping out the required system scope. This introduces deliberate friction. Bob prevents the generation of a single line of code until the human engineer reviews and locks the architectural design. Forcing this scoping phase up front isolates the design logic. It prevents the cascading failures that plague AI tools when they try to rewrite systems they do not fully comprehend. With the design locked, Bob transitions into code mode. It is specifically built to handle deeply entrenched legacy languages like COBOL and RPG. As it migrates those older batch processing systems forward, Bob treats modern enterprise Java as a first-class citizen. The primary execution interface for this execution is the BobShell command line interface. Beyond executing commands, BobShell captures and creates self-documenting, repeatable, agentic processes. This guarantees strict traceability and auditability for enterprise compliance. This diagram illustrates the core architectural advantage operating behind the CLI: multi-model orchestration. When a task is submitted, Bob evaluates it against a routing matrix. Every microtask must pass through 3 strict filtering gates: accuracy requirements, latency thresholds, and computational cost. Based on those filters, Bob dynamically routes the task to the optimal model, whether that is Anthropic's Claude for complex reasoning, open source models like Mistral, or the highly efficient IBM Granite family. Once a model is selected, specialized agents take over, coordinating changes across the codebase, test environments, and deployment pipelines simultaneously. Dynamically routing tasks eliminates the bottleneck of a single monolithic LLM. The most efficient computational engine solves each specific microtask. As code is generated, the action moves directly into the local integrated development environment. Alongside writing the application logic, Bob automatically generates comprehensive test coverage and the required automation frameworks. Security operates by design. Real-time policy enforcement runs continuously in the background, analyzing the developing architecture. Bob actively scans for sensitive data and intelligently detects exposed secrets directly within the IDE, catching vulnerabilities before a single commit occurs. This architecture diagram outlines the Model Context Protocol, the secure data bridge connecting the local workspace to external enterprise infrastructure. MCP allows Bob to seamlessly pull context from and push data directly into the external tools your engineering team is already utilizing. An AI agent operates blindly if it remains siloed. The Model Context Protocol gives Bob the critical ability to base its automated decisions on the company's live, proprietary operational data. With the application modernized, tested, and secured, the workflow shifts to deployment and operations. This sequence maps a standard continuous integration and continuous deployment pipeline, where Bob integrates directly. Instead of passively watching a build fail, Bob actively predicts deployment failures before they happen, catching integration errors and automatically rerouting them for correction. It then manages the safe promotion of these newly modernized applications across testing, staging, and production environments. Finally, the workflow reaches the most frequently neglected phase, ongoing maintenance. Bob continuously analyzes the newly updated project files and repository structures. It uses that structural analysis to automatically generate and maintain up-to-date documentation, ensuring README files and API guides reflect the live system. Automating documentation guarantees that teams do not immediately accumulate the exact technical debt they just spent months eliminating. We have successfully tracked a single feature request from unstructured text all the way through a deployed, fully documented modernization. This execution relies entirely on the multi-model routing framework to optimize every step for computational cost and latency. The BobShell CLI ensures that every agentic action is fully repeatable and ready for rigorous enterprise audit. And the Model Context Protocol ensures the AI remains deeply tethered to the reality of the enterprise's external systems. This fully interconnected loop illustrates a modern, AI-first software development lifecycle in action. The developer's role evolves into that of a director, overseeing a fleet of automated agents that execute the underlying architecture. Success in enterprise engineering depends on the intelligent orchestration of the entire software lifecycle.